Intermediate Algebra for Statistics. Graphing equations in the form y equals mx plus b and linear models. Part 2. Lesson objectives. State the rule of 4 for authentic situations. Perform a unit analysis of a linear model and graph equations of the form y equals b and x equals a. Lesson objective. We can describe an authentic situation by the following. It can be an equation. It can be described by a table, a graph, and it can be described by words. Let's look at an example. Example 6. List some of the solutions y equals 4x by using a table. Number 2. Describe the solutions of y equals 4x by using a graph. And number 3. Describe the solutions of y equals 4x using words. So we're taking an equation, y equals 4x, and we're going to describe it by a table, graph, and in words. Solution. So just like in the previous video, we are going to make a table. We're going to pick values of the independent variable x, substitute them into the equation to find the values of the dependent variable y. I picked -1, and when we put that in the equation, we see that the value of y is -4. When I substitute in 0, when x is 0, y is 0. When x is a +1, we have y as a +4, because 4 times 1 is 4. So we have our 3 order pairs. This completes the table. If we plot these points or solutions, we can sketch a line through them. So here we have, when x is -1, we have -4. When x is 0, we have 0. And when x is 1, we have 4. So to describe this in words, we would say for each solution, the y coordinate is 4 times the x coordinate. Lesson objective. We'll begin with the definition. Unit analysis. We perform a unit analysis of a model's equation by determining the units of the expressions on both sides of the equation. The units of the expressions on both sides of the equation should be the same. So the left-hand side should have the same units as the right-hand side. We'll begin with an example. Before starting a diet, a person weighs 160 pounds. While on the diet, she loses 3 pounds per month. So every increase a month, she loses 3 pounds. Let W be the person's weight in pounds after she has been on the diet for T months. Number 1, use a table to help find an equation for T and W. Number 2, perform a unit analysis of the equation you found in part 1. And number 3, predict the person's weight after she's been on the diet for 6 months. Okay, I think the first thing that we need to do here is to identify the independent and dependent variables. So weight depends upon how long she's been on the diet. So that means W depends upon T. T is our independent variable, time, and W, weight, which is measured in pounds, is our dependent variable. W depends upon T. So solution, we're going to begin our table. 0 months on the diet, this is the starting point. We have 160 minus 3 times 0. The first month, when T is 1, we have 160, but we decrease by 3, which gives us 157. So in 1 month, she loses 3 pounds. She weighs 157. Now I'm expressing that as an expression. So that way it will be easier to see the pattern and it will be easier to write the equation. So when t is 2, we have 160 minus 3 times 2. 3 months, we have 160 minus 3 times 3. So we can see the 160 is a constant and the minus 3 is a constant. But what changes is our variable here, t. Here's 4 months, and if we do t months, the equation becomes 160 minus 3 times t. That is our equation. So for this situation, it can be modeled by the equation w equals 160 minus 3 times t. Next, we're going to do the unit analysis of the equation w equals 160 minus 3t. So if we write out our equation, w, what's the units of w? That's weight. That was measured in pounds. 160, what's the units of that? Of course, that was 160 pounds, so it's pounds. The 3 can be thought of as slope. It's a comparison of two things. For every 1 month, the pounds decrease by 3. The way we write that is pounds per month or pounds over month. It's a comparison of two units. And t is of course time. It's measured in months. Now if you look here, we're going to use the fact that months divided by months, these are going to cancel. And when I say cancel, months over months is 1, and if we take 3 times 1 we get 3, so the units cancel. So what we have on the right side of the equation is pounds minus pounds over months times months. So these cancel. So we have pounds minus pounds. Pounds minus pounds, of course, is pounds. So on the left hand side we have pounds. On the right hand side we have pounds. So both the units are the same, and this gives evidence that our equation is correct. Number 3, if we substitute 6 in for t in our equation, we see that w equals 160 minus 3 times 6, which is 142 pounds. So we would interpret this prediction as the person will weigh 142 pounds after she has been on the diet for 6 months. Now, I should mention here that there's going to be some point in time where she is going to stop losing weight. And that sort of introduces the idea of what's called the domain and the range of a model. And that will be in future videos. Lesson objective: equations for horizontal and vertical lines. If a and b are constants, that means it's a number that stays the same, then the graph of y equals b is a horizontal line, which looks like this. There is our y-intercept, and it turns out that the y values stay all the same. For each of these x's, we have the same value of y, which in this case is b, some number. The graph of x equals a is a vertical line. So each of these ordered pairs on this line has the same x, and the y's are different. This line here is written in y equals mx plus b form, where m is 0, the slope is 0. This is the only linear line that cannot be written as y equals mx plus b. So let's do an example. Sketch the graph of y equals 3. So in this case we see that b is 3, and that means for different values of x, the value of y is the same, 3. So we know this is going to be a horizontal line, And if we plot these points, when x is -2, we have a 3. When x is -1, we have a 3, so on and so forth. Connect these, we see it's a horizontal line. The slope of a horizontal line is 0. Let's do another example. Sketch the graph of x equals 2. So for this one, x will stay a constant number, 2, and we're going to have different values of y. And if we plot these points, we see that x is a 2, but the value of y changes. We connect our points with this line, and we see that this is a vertical line. Now it turns out when we talk about slope, the slope of any vertical line is what we call undefined. And we'll discuss this in future videos. So to wrap this up, if an equation can be put in the form y equals mx plus b or x equals a, where m, a, and b are constants, the graph of the equation is a line. It's what we call linear. And the fancy way of saying these types of equations is linear equations in two variables. And we say two variables because we are referring to the variables x and y. Thanks for watching.